Hello, my name is Julian Brinkley, and this is CIS 3303, Object-Oriented Analysis and Design. Today we're going to be discussing domain models. So what is a domain model? Basically, the domain model helps us to build the system effectively by facilitating our understanding of the system. And what that means is the domain model, probably above all of the other models of the system, really helps to facilitate our basic understanding of what the entities are in the system, what the problem domain is, so on and so forth. It really encapsulates that big picture problem and what it is we're trying to accomplish with the system. So it's generally considered to be perhaps the most important model that you're going to develop within the context of object-oriented analysis and design. Um, the domain model is sometimes considered to be an informal or high-level class diagram. So the domain model does not go into object-oriented class diagram specifics like polymorphism, inheritance, and things like that. But it really documents the entities that are at play within the system from a high level. And what the domain model does is basically represent what you've learned about the system and the business entities, the relationship amongst those entities, and the relationship between the entities and the business context itself from a high level, and it encapsulates that information that you've learned from producing vision and scope documents, software requirement specifications, any interviews you've done, so on and so forth. It's a static model, meaning that it's not dynamic in the way that it actually interprets the interactions between the system. And it basically contains entities that represent key abstractions in the domain. So your users, customers, products, accounts, things that are well understood to be basically things within the actual problem domain or the context within which you're developing the system. And if you've already read the text before watching this lecture, this graphic should be pretty familiar to you. This is an example of a domain model, and this is basically a model of the Monopoly game. So in this context, we can basically see that and some of this in terms of the multiplicities and the relationships will become more clear to you as we go through this lecture. But just to kind of break down a little bit what this diagram is specifying, each player is actually associated with one game piece, and each game piece is associated with one player. Each piece is on one square, and there are 40 squares on the board, and each board is associated with the Monopoly game. Each game is played with 2 die. Again, the relationships, the multiplicities, etc., will become more clear to you as you read the actual chapter 9 in the text, and as you watch the remainder of this lecture. So we've talked a little bit about what a domain model is and have looked at a high-level domain model of a Monopoly game. But let's talk a little bit about what a domain model is not. A domain model is not a class diagram, and I mentioned that a few moments ago. So it doesn't include inheritance, it doesn't include polymorphism, you aren't talking about methods, so on and so forth. It is not a class diagram. Uh, the class diagram really emerges out of a discussion of the domain model, and that's something that we're going to do in the future, but the domain model itself is not a class diagram. The domain model is also not set in stone. Like most of the documents, diagrams, models, etc., that we're going to produce, these documents, diagrams, and models basically evolve as you get more information. So as you get more input, you evolve these models. So it's not set in stone. It's not as if once you produce it, that's just basically the end of discussion. So when do we develop the domain model? There are different schools of thought on when the domain model is actually developed. Some people and some practitioners recommend developing the domain model prior to the process of capturing use cases. Some say it's appropriate to do it during that process, some say after. My best rule of thumb is that it makes more sense to develop the domain model after you've gone through the process of capturing use cases. Because if you do that, you can use the use cases as input for the domain model, and it just makes the entire process so much easier than what it would be otherwise. By the time that you've actually captured use cases and you're actually sitting down to do the domain model, you should have a very good understanding of what that system is supposed to do, uh, what your goals are with the system, who the users are, so on and so forth. It's just you have a much clearer picture of exactly what's going on as opposed to trying to do this earlier in the process. And so this really emphasizes the importance of some of the previous steps that we've gone through thus far within the course. So your vision and scope document basically helps you to describe what you're building, kind of helps you restrain the context. So without getting too carried away, it helps you kind of narrow the scope somewhat. And it really informs the development of the software requirement specification. The SRS then helps you to document what the system does and informs the development of the domain model. So with the SRS, you're really spelling out, especially with the addition of the use cases, what the system does, while not really going into details about how it does it. The domain model then serves as more or less a capstone of that process, or that initial process anyway, and captures the system entities, the relationship between entities, and it basically informs much of the remainder of your UML modeling process. So the domain model is basically used as a platform from which you're going to develop the majority of the remainder of your models. So in a nutshell, good use cases can make the domain modeling process easy and even fun. I really enjoy the domain modeling process. It's my preferred model. You know, if I had to pick one model out of the whole context of UML, it's going to be the domain model because it really gives you a full picture of what the system is supposed to do. So the domain modeling task is the process of discovering objects and basically defining relationships. So it's more or less a two-step process. The final model should conceptually represent the real world or the actual problem domain. It's going to contain the entities or entity classes that are needed for application development. And again, just to go back to something that we've covered in previous lectures, some of the terminology that we're going to use in this context is somewhat overlapping. So I believe in the text, in some places, it uses the term classes. In some of the literature that you'll look at, it refers to classes as entities. I tend to refer to objects in the domain model as entities. So the things as entities. I think that is a more straightforward way of referring to what we're talking about. But in either case, the domain model will be used as an input for the creation of class diagrams, which are basically going to contain a subset of the information that is in the domain model. You don't necessarily have to have one class diagram that specifies everything. It's not uncommon to have multiple class diagrams, which will specify different sections of the actual system. It just improves the ability to actually make sense out of the class diagrams themselves. So, a couple tips on the domain modeling process. While the process is very important, don't get really stuck in the mud. Oftentimes, it doesn't make sense to try to model everything in the first go round. For the most part, the best approach is the same approach that we're going to use throughout the concept of modeling and diagramming, etc. You want to create a baseline model and then basically refine that model. Oftentimes it makes much more sense to do that than to try to shove everything into your initial model and have that pretty much set in stone. So the first step in the process is to discover objects. So by the time you start the domain modeling process, the hope is that you've conducted interviews, that you've developed the business case for the system, that you've written a vision document, that you have a project charter instead of the vision document, that you've written some initial use cases, basically that you've done some deep work into or put some level of deep effort into understanding what exactly you're building and why you're building it. Because without that level of knowledge, it's not going to be very easy for you to basically specify things in a domain model. You're not going to have the appropriate information to do that in most circumstances. But assuming that you've done all that, you want to mine all of those sources for information about what the system does, and then you want to go through a process of basically writing down the nouns that are discussed within all of those documents. And you should have some form of documentation from those different processes. And by nouns, not that we're in an English course, but it's important that we understand what we're talking about. By nouns, we're talking about the people, places, and things. And perhaps the best source when we're talking about the vision document, project charter, SRS, so on and so forth, perhaps the best source is the written use cases. If you have good use cases, it makes it much easier to go through the process of producing a domain model. You have all that information in one location, and you have a very good understanding of who the users are, um, what the user entities are, and what the system is supposed to do. So it makes it much easier just to go through the domain modeling process. So as an example, we're going to use the create widget use case from our previous lecture as an input. So, and just to go back through that, in the create widget use case, an existing user visits brinkley'swidgetfactory.com with the intent of creating a new widget. After authenticating the user, the system prompts the user to enter the details for the new widget. The user enters and confirms the details of the new widget. The system creates the widget and displays the widget details. The user receives confirmation from the system of new widget creation. So, we want to identify the nouns. So, what are the nouns? What are the people, places, and things? So, we have two within this use case. We have the user, and then we have the widget. Those are two things that we're going to be talking about. So from there, we can basically draw those two entities that we've basically pulled out of the use cases, out of that use case. The user entity and the widget entity. And we basically represent these as rectangles, like a little box. The top portion of the box basically is the description of what the entity is. And then we'll use the bottom portion of the box to basically write down our attributes. And to put together a list of entities, which is the first thing that you want to do, you want to go through all of your use cases and follow the same process in terms of identifying what the things are, what the people, places, and things are, until you have a full list of entities. So you're then going to take that full list of entities and basically make a list that you will use to create these boxes. After you've identified all the entities, you now want to go back and add attributes to these entities. The best way to think about an attribute is to think about it from the perspective of something that the object has, like a property. And for those who have done some object-oriented programming, perhaps the best way to think about it is to think about it like a property. That is really the most straightforward way of thinking about it. But when you're specifying attributes, you're going to want to use your own judgment, and you're going to want to think logically about what the attributes are of each entity. So in the example that we're using, at a minimum, we know that our user is going to have a name and that our widget is going to have some type of identifier. The widget's probably also going to have a name, but at a minimum, it's going to have some type of identifier that allows us to identify which widget we're talking about from the list of widgets that we've created. So after you've gone through the process of discovering objects, you then want to start the process of defining relationships. So you want to mine all of your previous sources, your vision document, software requirement specification, your project charter if you've done one of those, so on and so forth. You want to mine all of those documents for verbs or descriptions of an action. So examples could be when we talk about creating something, deleting something, updating, ordering something, drawing something, configuring, posting, uploading, sending, scheduling. Generally, in a use case, it will look something like X creates Y, or X deletes Y, or X updates, so on and so forth. So we're talking about one thing does something to another thing. And that's generally the best way to go through the process of identifying our verbs. So using the same use case as an input, what would our verb or verbs be in this context? From the use case, we would likely be able to draw one relationship, which would be the relationship between the user and the widget that the user actually creates. So in this use case of create widget, a user actually goes through the process of creating a widget. So it's pretty straightforward. We would then represent this relationship with a line that connects the user to the widget. So that single solid line from one box to the other box shows that the user is in some way, shape, or form associated with the widget. Now, after we have defined the relationship, we now want to actually define the multiplicity. And when we think about what multiplicity is, we can think about it from the perspective of relationships. So entity X is associated with entity Y and how they are associated with one another. How many users, for instance, are associated with widgets and vice versa. So in our system and in the use case that we described, users directly create widgets. So they aren't in and of themselves created by the system. They're created as a result of an action from a user. So users can have 0 to an infinite number of widgets because we haven't actually specified that there's a cap. And we would represent that by a 0 and then almost like an ellipse, but 2 dots and then 2 periods or what have you, and then an asterisk, which basically represents that each user is associated with 0 or an infinite number of widgets. So we can have a user account and we may not necessarily have any widgets. That in fact, once we initially create a user account, that's the state of affairs. We don't have any widgets that are associated with that user because we haven't created any yet. So we can have either a 0 number of widgets for each user or an infinite number because we haven't specified that there's any type of cap. If there was a cap, let's say for the sake of argument 200, then it would be 0 dot dot 200 widgets, which would basically say that each user can have 0 to 200 widgets. So how do we specify the inverse of that relationship? Each widget is associated with a single user. So we would represent this by simply placing a 1 next to user above the relationship line. Now, if each widget could be owned by 3 people, then we would say each widget is associated with 3 people, or 1 dot dot 3, so 1 to 3 people. So we would put that range there. If each widget could be owned by 1, 2, or 5 people, then we would specify that relationship by saying, or by placing a 1, then a comma, 2, then a comma, 5, specifying that we have a set where each widget can be associated with 1, 2, or 5 users. But in this case, each widget can only be associated with 1 user, so we simply have a 1. So we would discuss this entity relationship when we actually read it as each user is associated with 0 to an infinite number of widgets, and each widget is associated with a single user. And basically what you want to do, the domain problem is as simple as that. I know there is a lot of information that's discussed within the text, but the domain modeling process is as simple as doing that same process that we just did very briefly. You want to follow that same process and go through and identify all of your entities and then specify all of your relationships and multiplicities. At the conclusion, you should have a domain model that basically outlines all of your entities and identifies all of the relationships and multiplicities. And a couple tips. You do want to use existing names and terminologies. So one of the key things, and this goes back to just producing good documentation in and of itself, you want to make sure that you're being consistent with the other project artifacts. So if you called a user a customer in your use cases, you refer to a user as a customer in your project chart or vision document, you want to also refer to them as a customer in your domain model. So you want to have that level of consistency in what it is that you're producing. You also want to think about the larger business context or just a real world that your system exists in. This really goes a long way toward a long way towards helping you understand what you're doing, and it just helps generally with the modeling process. At the conclusion of modeling, your model should be very straightforward to the point to where you can look at it and logically understand what the entities are and what the relationships are. If it's overly convoluted, you've probably done something wrong. Do not use hard to understand names for your entities. So the model again should be as easy to understand as possible. Don't use any type of shorthand when you're describing what your entities are. So if something is a portfolio manager, for instance, don't use any type of abbreviated shorthand like portfolio MGR or anything like that. Just say portfolio manager. Use very straightforward and clear language when you're describing entities. And do not think about classes while modeling beyond perhaps thinking about actual properties, which helps a little bit with the attributes. You're going to have time later to think about inheritance, polymorphism, method, so on and so forth. That's not what you're doing at this level of the process. This level, you're producing a domain model, not a class diagram. You'll have plenty of time to focus on the class diagram and functionally decompose what it is you're producing as you're moving forward. So in terms of your homework, you're going to produce a domain model of your system that's going to be due on September the 25th. You're also going to want to read Chapter 9. That's going to cover in a lot of detail what you're doing in terms of the domain model. This lecture was meant to basically be a supplement to that and cover the core information and specifically how you would go through the process of producing a domain model in a quick fashion. The chapter really goes into a lot of detail in terms of the ins and outs of the domain model, some of the verbiage, so on and so forth. And you also want to do quiz 5.